Welcome to the latest demo for my custom programming language called Fae, spelled F-A-E. I want to talk about the latest feature I've added to the language, which are struct field visibility modifiers, which combine in a few different interesting ways to allow developers to write data structures that have a greater granularity of control over what data is and is not mutable by who, without having to resort to writing getters and setters. So I have a little demonstration struct here with a single field called myField, which contains an int, and I construct a copy of it. I assign one, I add assign one to that field, and then I print it out. I just have this little helper function here because the language does not currently have very nice printing mechanisms. So this is just, we're going to be printing a fair bit, I think, in this demo. So I want to do that. So we see here, as expected, it prints 4 because we initialized the field with 3, and then we add 1 to it, and we print it. So if I come over here, this field by default is public. Everyone in the program can read and write to this field if they have a mutable copy of the struct. Fae is a language with mutability. If I come over here just to demonstrate this and change A from mutable to immutable, we're going to see unhappiness. The compiler is going to tell us cannot assign to field of immutable object, and we are not happy. If I come back over here to make this mute again, the compiler is once again happy. And this field is accessible by everyone in the program. That's the default. Fae defaults to everything's public by default, and you have to specify otherwise because data is just data, and unless you're building something very specific, that should be the default assumption because this is a language without destructors, without higher level memory management mechanisms. It's a language about data and the code that operates on it. So everything's public by default. But let's say you don't want that. You want this field to be readable by external, but internally mutable. Well, we can tell it that it's readable. Now, if I run this, we're going to get 2 separate errors. The second error is the one that you were expecting, because I've said that this field is only publicly readable. You cannot modify it outside of the methods on that struct. The struct doesn't currently have any methods, but we could imagine it does. We'll get into those later. We could imagine that it does, and those would be able to modify this field still. But we are not in a method. We're just in a normal function with just an object instance. And so we are not allowed to publicly assign to that readable field. Now, the first error is a little bit more unexpected. Cannot publicly initialize readable field, myField, on type myStruct. This is because it feels a little odd to be able to initialize a field to a specific value if you then can't modify it further publicly. So unless you're in a method on this struct, you cannot initialize this field. And we can get around this now by creating a constructor for this type. And again, structs in Fae are just data, so we don't actually have constructors. We have static methods. So I can say method static myStruct. And we'll call this new. And we could accept a parameter here. I'm not going to. And this returns a myStruct. And I want to return myStruct. And I'm going to separate this one across multiple lines because we're going to start adding fields to the struct at some point. So I want this to be nice. My field. And we'll say that this is 2. And so now I can come down here and initialize that. And so now that error has gone away because it's internally readable. It's also internally writable. Cool. So this gets rid of the need for getters. That's the most common use case for this, is I have some sort of field that I want the external world to be able to look at and inspect, but not modify. And I don't want to have to write a get myField method because that's annoying and I don't want to have to do that. As a quick example of when this might be useful, if I come over here to this file, this is the generic list type in the Face Standard Library that I wrote in the previous demo. You can go find that on my channel. And here, when you have a list, you might want to be able to get the pointer to those lists, those items. And so the pointer in the list is readable. And so is the capacity, because you don't want to be able to modify the capacity, because that then breaks the internal assumptions of the list. However, length, modifying the length of the list, is a thing that you might want to do in specific circumstances where you're using list as a buffer. And we did do that in the previous demo, where we wrote a file type as well that has this read until new line that reads into a list of U8, list of bytes, as a buffer. And it wants to be able to read reserve a specific amount of capacity, and then read into that capacity, and then shrink the length, set the length to the newly read stuff, reaching behind the curtains. And so it can still do that. In the previous demo, we had a method here for set length. That no longer exists. Very cool. But that's not all. We also have private. Let's come over here and let's do that. So this runs. We're still readable. I'm no longer trying to mutate a dot my field outside the struct. So we're safe here. We're happy. The compiler's happy. It's 2. We haven't modified it, so we're just printing the 2. But if I come over here and say you're private, oh no, cannot publicly access private field on type. Well, that seems as expected, not too complicated. Interestingly is the next one, read only. This is where the system gets a little bit complicated, and I've racked my brain on how to solve this complexity for a few years before I started working heavily on Faye, and I haven't come to a design that I truly love. This is the best I've come up with, and it's not that bad, but the rules are a little bit intertwined, and it's a source of complexity I don't love, but you'll see what I'm talking about in a moment. So I've just said that this field is read only. If you look, I can run that. Everything's happy. We're publicly accessing it. We're internally assigning it. Everyone's happy. Well, we're internally initializing it. But if we have a method that we want to assign to this, let's do this out externally. So this might print 3 if the compiler didn't reject it. The compiler does reject it. Cannot assign to read-only field, my field. Now what's interesting about read-only is that it's read-only everywhere. So if I create a method, my struct, and we need mutable access to my struct, and we want this to be increment. This doesn't return anything. And we just have self.myField plus equals 1. Okay, you say. Compiler might be happy with that. No, it's not. Can I assign to read-only field, even though we're inside a method? Because it's read-only everywhere. Once it's been initialized, you can't modify it. I have had times where I've been building some sort of data structure and I need some sort of pre-initialization, some sort of handle to something, and I don't really want to modify it. I need to have it be different in different instances of the object, but I don't really care about being able to modify it. And in fact, I'd like the compiler to be able to catch that. I don't know if this is truly that valuable, and this system would be incredibly simple if I were to remove read-only, but I want to try it. Here's where it gets complicated. Readable and private can both be further annotated with read-only. So if I come over here and say readable, all of a sudden we're happy. We'll print the 3 because we're internally initializing it, we're internally modifying it, and we're externally accessing it. That's happy. We're fine because it's readable. It's internally mutable, assuming you have a mutable access to self, of course. If I change this to a non-mutable method, it's not going to be able to access it because it does not have mutable access to self. Cool. That's fine. But we're internally initializing it, internally mutating it, and externally reading it. If we were to come in here and try to modify it externally, once again, we'll get an error just to make sure we're setting the stage. But I can come in here and I can say read only. No, wrong order. Readable, read only. So now this is readable externally and read only internally. Now technically these overlap slightly, because if it's readable only externally and it's read only, it's still read only externally. There's a little bit of overlap there, but this also means it's read only internally. So now I run that, cannot assign to read only field, even though we're inside the method. A little odd. And then of course, there's private read only, where you can't modify it internally and you can't access it externally. It's not that complicated, but it's a little bit of intersection that's a little bit odd. But I like the utility that these three keywords give. They're not actually true keywords because of where they are in the syntax. They aren't true reserved words, which I'm quite happy about. I really didn't want to have to add more reserved words to the language for this, which would be required if I were to come over here and say private read only. What I know some languages do, and this is what I was planning on doing, is coming over here and prepending some sort of symbol to the beginning. I've done this in the past for other things. If I open up the, let me undo that just so I'm back in a syntactically valid state. If I open up the prelude, we have some intrinsics here which are tagged with that, and that's fine because these annotations are only allowed within the standard library, and so you'll never see this in user code, which I care about because that's butt ugly as far as I'm concerned. There's also, if I go into runtime, there's laying items for user code things that the language compiler needs to be able to reference. For example, this is the function that the compiler emits a call to for when a slice bounds check failure occurs, when you try to index into a slice and it's out of bounds. Again, you can only write these in the standard library. Like the compiler will refuse to let you write these outside the standard library. So it's fine because they're ugly, but they're contained within the standard library, and there's only a handful of them, and so fewer reserved words. So I'm quite happy with this. Am I in a building state? No, I'm not, because I'm modifying this. And of course, we're back to private. I removed the read only, so internally I'm allowed to mutate it, but externally I'm not allowed to read it. Very cool. I'm happy with how this system turned out for the most part, because it didn't turn out to be as complicated from the user's perspective as I thought it would be. And in fact, demoing it now has made me feel a little bit more confident about that, which I'm quite happy with. Only took about a day to implement, and I'm quite pleased with the compiler internals letting me build this as quickly as I did. There's more stuff to do. I gotta have struct, function, and method visibility next, which is going to be fun. I still don't have enums in the language, which are coinciding with unions and pattern matching, because those all go together because they're going to be algebraic subtypes is the technical term. Tagged unions, but as a language concept, Rust enums. And that is kind of partially blocking having proper printing facilities, but not fully. So yeah, I'm happy with this. I think this is a really useful set of features for controlling the visibility and mutation of struct fields, and I'm excited to use them in practice. Writing code in Fay. Thank you very much for watching, if you've watched this far, and I will demo more later.